Morning. So, who here ran RubyConf 5K? Okay, awesome. Who here got a RubyConf 5K t-shirt? So, I heard that you actually have to earn these t-shirts. So, if you got a t-shirt and you didn't run the 5K, you're going to have to do it this afternoon. So, I had a really good time running the 5K this morning, and for those of you that don't know, 5K stands for 5,000 kilometers. You may not know this, I'm from the United States, we don't have the metric system there, so this might be wrong. So, I want to say welcome to everybody here. I'm really excited to be here. I'm excited to be the first person to welcome you to RubyConf India. I really want to say thank you. I'm incredibly honored to be here. I want to say thank you to the conference organizers, and thank you to the sponsors, and thank you to all of you for being here. I am so happy to be here. I've never been to India before. This is my first time here. I love Indian food, and this is actually really bad for me, as you'll see later. You'll see it later. It's actually pretty bad for me. But yeah, I'm really excited to be here, and I'm also honored to be here to follow some awesome keynote speakers. We saw Jim yesterday with some excellent refactoring, and sit on with the Hawaiian developers. That was an amazing performance, and also Steven's talk after that was about functional reactive programming. I can't say it, it's too much. He says it's FRP, but I just keep thinking, for her. Anyway, my name is Patterson. You can find me on the internet as Fiddle, on GitHub and Twitter and all that stuff. And I may look weird to you on stage here on the internet. I don't look blue. But the thing is, on the internet, are we on that side?
That's being vector map.
Yeah. Wait, jiggle the laptop or myself? Anyway, so, okay, there we go. So anyway, on the internet, I look a bit like this. That's what I look like at home. I actually like to wear a suit when I'm on stage so that people will take me seriously. So I work for a company called AT&T. I'm an open source developer for AT&T. I work on open source all day. I'll talk about that a bit later. I'm on the Ruby core team, and I'm also on the Rails core team. I think I'm the only one on both, but that might not be true. I'm not sure. Also, recently I bought a Google Glass. Amazing. Any of you bought Google Glasses? No? Oh, well, I'll show you a picture. It's really awesome. This is my Google Glass. It's really convenient. I don't know what the big deal is about it, but it's I find it handy. So I like my Google Glass. I'm actually going to post some later when I get back home. I'm going to post some teardown videos of it. So how it's built. I love cats, and I have a cat. This is my cat. He only speaks Japanese. I don't know why. I have no idea why I translated their spot. That's what he's saying. His name is Gorbachev Puff Thunderhorse III. So I thought it'd be really awesome to get a cat. I was super excited about it. Got a cat. I thought we would be hanging out all day, going to the park, riding bikes together and all that stuff. But it turns out he actually just sleeps all the time. Literally all the time. Try to take a picture of him, he's just yawning everywhere. He's not thing is, I actually have two cats. So this is my first one, this is Untitled Chapter. This is the other one. Her name is SeaTac Airport YouTube. Come talk to me later, I'll tell you why she named that. So we have, okay, I study these cats. They're pretty cute, I study them. We have these two baskets. And this is what it looks like from the top. We've got two baskets and a cat sleeping, right? One basket for each cat. But for some reason, I don't know why they do this. They sit in the same freaking basket. So I take a picture of them, like, why are you guys doing this? What's the deal? And then so they're getting annoyed with me taking pictures, and like, okay, we're annoyed. So they decide to leave, and then they both move to the same freaking basket. Now they're alone. Why do they do that? I don't get it. I really don't get it. Anyway, so enough about my cats. That's not why we're here today. Let's do some actual real stuff. I want to say, like, so I am not a keynoter. I'm absolutely not a keynoter. I am a programmer. I'm a hacker. I'm not very good at speaking, I don't think. I'm much better at programming. So today, what I'm going to share with you is I want to share some hacking on stuff. We're going to hack on things, hack on Ruby, and then we're going to do some Rails stuff. Like, I feel obligated to talk about Rails. I'm on the Rails core team. I probably ought to talk about it while I'm here. And then we're also going to talk about some open source stuff. Like, I want to talk about doing open source, my experience with open source programming. And so I'm going to start off with some stuff, some irresponsible Ruby leading from what Stephen was doing yesterday. I want to do some of my own here. And mine is, like, I don't know, Stephen's was probably a lot more useful than mine is. But I'll show you here, and I think we'll have a little bit of fun. First, I want to talk about Ruby values. So these are the objects that you deal with in Ruby, just any particular objects. We call them values. If you go look at the C code, they're all called values. And there's two types. You can break them down into two types. There's immediate values, and there's regular values, just regular objects. Two types of objects, immediate and regular. So the immediate ones are nil, true, false, and fixnums, integers. And this is right here is the formula for calculating what fixnums are immediate values. Any number that's greater than that formula returns to you of your architecture, that will not be an immediate value. I believe also floating point values are. I think doubles are immediate values as well, I don't remember. But here's some immediate values, and some interesting aspects of these are that these objects are actually singletons. There's only one of them in the system. And what's kind of cool about them is that they're never allocated because they're just represented as integers. They're just stored as integers inside of them. They're never allocated, and they're never garbage collected either. So they just sit there forever and ever, and if you go check out the object ID of any particular one of them, it'll always be the same. And what's kind of cool is we can actually perform a few little tricks with fixnums, and the stuff that I'm going to show you today, it only works in MRI, period. It doesn't work, it may work in other Rubies, but it's not guaranteed to work on anything besides MRI, and you should never use this code in production that I'm about to show you ever. But you should try it. Please try it at home. Your laptop or your desktop, it'll be fine. Your computer will not blow up, I promise. Actually, does anybody remember configuring X on Linux? Like configuring the graphics card, you go through. I used to configure the graphics card, and there was there was this like text thing, and it was like you x386 config, xf86 config, and walk you through all this stuff, and then you get to the graphics card section, and it's like, be careful with these values, because you can blow up your monitor. Are you freaking kidding me? Blow up my monitor? What value should I put in here? Super scared. I never actually blew up my monitor, but I'm like, so there must be accounts of this somewhere on the internet. So if you've actually blown up your monitor configuring X-Link, let me know. I'd love to know about the story. Anyway, so I want to show you a trick that you can do with fixnums. If you take a look at the object ID, just call object ID on it, and then right shift that over one, it'll actually give you back the value of that fixnum. So that's how you can tell the object ID mapping of these fixnum values. So we say, okay, new object, and if you look at the inspect there, you'll see, there's some address there. And you may know that that address there on the second line, that's actually the address in memory. That's where it's located in memory on your computer. Now, if you do object ID on that, and you call 2F16 and try to get out a hex value as the object ID, it doesn't look the same as the memory location. You think, well, isn't the object ID the memory location? Like, it must be unique. Where is this value coming from? And well, it turns out that that object ID is actually related to the memory location. You just have to left shift it 1. So if you shift that ID over 1 and then you get the hex value of it, you'll see down at the bottom, that hex value is the same value as what was printed in the inspect. So now we can see how the object IDs are actually related to the memory location of your objects. So let's do something with that. Let's fiddle with the memory. This is one thing I love about programming with Ruby, and actually one thing I like about being a C programmer is that you can mess with memory. You can just reach into memory and mess with it and do whatever you want to. There's no restrictions on it. And of course, that means I have to deal with segbies all the time. Nobody likes that, but I guess I don't know, hate myself or something. Anyway, so what I want to do is I want to fiddle with memory. I want to mess around with memory. We can actually do this in Ruby, and I'm going to show you how. There's a library in the standard library called Fiddle, and what it will do is it will actually give you a Ruby object that represents a particular location in memory on your machine. This is how you use it. So you say, okay, I want to get a fiddle pointer, you require fiddle, and you say, I want a new pointer, and I want it at this particular offset, this location in memory, and it gives you that location. It just points right there, and you can treat it like an array. So you can say, okay, give me the char value at that location in the array, and it'll just give you the value in memory with the width of a char. So you can see what that is, and you can actually set values there too. So you can actually manipulate the memory to set a value. Okay. So let's do something with that. Let's take a Ruby object and we can get a pointer to the location in memory where that Ruby object exists. So this particular pointer there, it actually points in memory on your machine to where that Ruby object is. Okay, so we have a pointer there. We can read the memory, but what can we do with this? Well, let's take a look at how Ruby objects are implemented in MRI. This is the actual C struct layout of Ruby object. So this is our memory map for this particular value. You can see there at the top we have a struct R basic. So that's going to be at the very head of every single Ruby object in the system. Okay? Now, all right, let's take a look at what an R basic is. If we look at an R basic struct, we see that the first value is flags, and the second value is, what is the second value? It's a class. Okay, so we have flags and we have a class. These are going to be at the very beginning of every single Ruby object in your system. So, okay, what is a value? You need to look at the type of a value. If you go look at the header files, you'll see, well, it's a UN pointer, a T, and we can get the size of a UN pointer T on my system. That's a width 8. It's 8 bytes. Okay, so we know how wide a value is now, and we know where these values are stored in memory. So let's go read one. So we have this object, we have our pointer to the object, and we say, okay, I want to read 8 times off of that, for that size. We read it 8 times off, and we get this value. Okay, that's cool. So we got the flags. We were able to read the flags for this. Well, flags are kind of interesting, but it's just a bunch of 1s and 0s. I want to see something a little bit more fun. Let's take a look at the class. So we'll read another 8 bytes off of this. This says, okay, read I plus 8, so we want to get 8 past the flags. So these are our values, but we know that this value is a UN pointer T, not a bunch of char width values. So what we're going to do is use Ruby's pack to put them together into an actual integer. So we do that and say, okay, well now we've got an actual location there on line 4. That's the location in memory of the class object. So we combine all those values together, we get the location in memory, and then we can get another pointer to that location. And we can see, okay, my object is of type object. Down there at the bottom, pull that out of the C structure. Okay, well, that's nice. Pull it out of the C structure, but it's nothing crazy. Why do we care about this? I mean, we can just call .class on our object and get the same value. This isn't very exciting. What would be more exciting is if we could set the class. I would like to set the class, and the way that we do this is we say, well, okay, let's get the object, let's get the offset, let's go through and actually write to that offset. So we get the string objects, the offset for the string class, and then we go in and set that class offset inside of the Ruby object. So now we turn this O, that's just a normal object, we turn it into a string. So I want to show you this actually in action. Okay, so we start with IRB, we say, okay, here we've implemented class equals, which does all the stuff we looked at in the slides. We included that in an object, and we say, okay, let's create a new object. Great. Let's say O.class, class is an object, and we'll go ahead and set it to a string. Now our O is now a string, and it actually inspects as a string. So this is we're able to manipulate the class values on any arbitrary object in the system. So, let's do some more. Let's add a singleton class. Why do we do that? Yes. Okay, so we'll set it to a singleton class. We'll look at, oh wow, okay, it's something crazy. And now we actually have the LOL method on our object. So, all right, we're messing with objects. Never ever do this in production, please. If you do this in production, I will personally come correct your code and maybe correct you a little bit. But all right, so we saw this crazy stuff, and it is crazy. But the thing is, like, I keep thinking to myself, you know, I love doing this stuff that's just crazy and irresponsible. But you know, like, I have fun doing it. But I think, well, is it useful? Am I actually learning anything when I do this? Like, getting anything out of this? And I think that the answer is yes, and I'm going to try to prove that to you. So let's take a look at querying a Postgres database. So we say, okay, we connect to the database, and we're going to select these values. We're going to select 1, true, false, and nil. And we're going to look at what Postgres returns to us. Okay? So, all right, we query it, we send that off to the database, and we say, give me the values back. And if we actually look at the array of values, we get the string 1, the string t, the string f, and then we actually get a nil there at the end. Right? Now, if you think about this, we actually have a problem because every one of these things, go clicker, every one of these things is garbage. Every time you get one of these values out of Postgres, you're going to have to say, okay, I got to take this integer value and actually call 2i on that. So you take that string, you convert the string into an integer, and you actually throw that integer, or you throw that string away. Because you don't care about the string, you just care about the number that's in there. The same thing with the true and false. You don't care about the string t, you care about the true value, you care about the false value. Now, we know that we're generating this garbage and just throwing the stuff away, but we also know about immediate values in Ruby, like nil, true, false. We know that none of those are ever allocated or garbage collected. So by messing with this stuff, we know, well, maybe if we go in and change the Postgres adapter, we say, like, well, let's just, instead of just returning the string 1, let's just convert it to a 1 in C and then return that to Ruby land and not generate this garbage anymore. So if we actually did that, we would get an array back like this, and we see there's 0 time spent in the garbage collector here with this. These values get returned to us. None of these are allocated, and none of these are ever garbage collected. So the point I want to make with this is that having fun is not wasteful. We were having fun doing this crazy code, but we were actually able to learn something from that and take these skills that we can apply these skills to our real world applications and actually come up with some performance improvements to things that we may do in production. So having fun with this crazy code is never a waste of time, in my opinion. I mean, you probably shouldn't be doing it at work. I'm not sure my boss would be super happy to find out that I was setting the class on some crazy object. But I was able to learn something from it and use this in production code. Use the skills I learned in production code. So the next thing I want to talk about is new stuff in Rails. This is stuff that hasn't been deleted yet. For some reason, I have an incredibly bad So what do? Double your commits. So I'm going to talk about a couple new things that are in Rails, and then we'll move on to some open source stuff. So first thing I want to talk about is UUID primary keys in Postgres. So in Rails 4, you'll be able to use UUIDs as primary keys if you're using Postgres. The advantage for using UUIDs is that you have a place to shard. You immediately have a place to shard a random value that you can say, well, okay, I want to take this table and now I need to split it up amongst a bunch of different databases. Where can I split this data? You already have a normally distributed key that you can distribute your data with. The way that you do that is you just say, okay, I want my ID to be a UUID. And now you have a UUID in Postgres. And the next thing I want to show you is we actually have HStore support as well. Postgres has a thing called HStore, and what this is you can store a hash inside of Postgres. So you can say, like, I want to store actually semi-structured data in Postgres, and you can actually query on these hashes too. So you can say, like, okay, give me all records where the hash column has a key with the value whatever. So those of you that haven't web scaled to use Mongo, you can web scale your Postgres database instead. And we actually support, I didn't put this in the slides, but we also support JSON inside of your Postgres database too. So if you have JSON columns, we can support that as well. So I think that's really exciting. The next thing is that we have faster tests. This is extremely exciting, faster tests. Okay, they might not actually be faster. We'll look at why they're not actually faster, but they seem faster. And really, I guess, like, perception is half the battle, right? If it seems faster, it is faster, right? So let's take a look at Rails 3.2. If you run some tests, this is just my simple app here. I'm running some tests, and on my machine it takes about 4.7 seconds. And if you run this against the betas or the RCs, Rails 4.0, you can see, oh wow, it takes 1.9 seconds. Wow. Same application, same test. It's reduced by almost half the time. That's crazy. Let's take a look at a graph. Oh yeah. Yeah, time. It's pretty great. Like, yeah. I worked a long time on Keynote with this one. You may not know this, but I'm actually a main. So how do we get faster? How do Rails get faster with these tests? The first thing we need to do is we need to look at where the bottleneck is, and I want to show you how we find this bottleneck. So let's run just one test. Rather than running the whole suite, let's just run one. See what happens. Run one functional test, and that takes 1.7 seconds. Okay. Well, let's try the same test in Rails 4. Well, that takes exactly the same amount of time. That's interesting. And now let's do another test. Let's just require the application itself. We'll just require the environment. We always have to require the environment before we run the test. So let's try requiring the environment and see how long that takes. No tests, just require Rails and be done. Well, that actually takes 1.4 seconds. Our test took 1.7 seconds. Requiring the environment took 1.4 seconds. So we can tell that our bottleneck is actually just requiring the Rails itself, requiring our libraries. Okay, so how does this fit into the testing picture? Okay, how does this fit in? So the way we can discover how this fits in is if we look at a regular old test task, this is a simple test task. We run the test. It's outside of a Rails app, it's going to be anywhere. We run the test. We run it, okay, we ran our test. Now if we look at the command to actually run the test, this is in verbose, this is the output when we run rake. If you look at the command, you'll notice right there we run Ruby. Right? Actually it runs Ruby. So we ran rake, running rake runs Ruby, and then the rake command runs Ruby again. So when you say rake test, that actually runs Ruby twice. Right? Once to actually start up rake, and once to run the tests themselves. Okay? So if you think about rake plus Rails, well, when you say, okay, we run our tests, and then that boots up the rake file, that shells out, and that calls Ruby tests on all of our test cases. So if we think about this, right here we're loading the application when we load the rake file. And then it shells out, and then again we load the application when we're running the rake, or when it actually runs the test cases. So running rake test units, that actually loads our app twice. Right? So now we understand why it was that when we ran rake test, it seemed so slow. Now if you run rake test, that actually loads your application 4 times. Once for the rake file, once for the units, functionals, and then also the integration tests. So we're loading the application 4 times. We have multiple loads that we have to deal with. Yeah. So I wanted to get rid of that. The way that we do this is we say, well, okay, let's just require the files. No more shelling out. So this is basically what our new test task looks like. We say, okay, if you give me a list of all the tests, just require them and then exit. That runs all the tests and it actually loads your application once. We load all the tests in the context of your rake file. Now we have some challenges with this. The challenges are that we have to switch the environment, because if you think about it, well, when you run rake, how do we tell what environment your Rails application is running? We don't know. We just assume that it's development. When you don't tell us what environment it is, we assume that it's development. But when you're running rake tests, obviously we need to run in the test environment. So we have to be able to switch environments. But the problem with that is that your app is a singleton. So we can't just throw your app away and then instantiate a new one. So there are some challenges with that. I already talked about what environment rake is in. So the way that we do it is we say, okay, well, let's change the environment before the application runs, or before the app loads. We'll look at the actual rake test, and if you go look at the Rails source code, there's some huge hacks for this. Like you'll see it. It'll say like, okay, are we running the test task? Yes, we're running the test task. Let's change the environment to test, and then load the application. So there's some hacks for dealing with this. But we also have to deal with stuff like, okay, you have pending migrations, and we have to test your development environment, whether or not you have pending migrations. So all this just becomes like a huge headache. We have some crazy hacks for this in Rails 4.0, which we'll see. But you know, if you think about the real solution, which I think we need to have in 4.1, well, we are going to have it in 4.1, is to remove the singleton. There's no reason your application has to be a singleton. I'm not actually sure why the requirement was put there. I think it was a case of defensive coding where somebody said, well, you know, we don't want them to instantiate their application twice. That's obviously a mistake. Who would ever want to instantiate their application twice? So let's raise an exception when they do it. When really there's no problem with it. If you wanted to instantiate your application twice, who cares? Like, if you're making a mistake, just don't do that. So let's talk about the newest stuff. I want to talk about caption. Newest stuff, and when I talk about newest stuff, like I want to talk about Rails 4.1. I'm tired of talking about Rails 4. This reminds me. Many of you have asked me, when is Rails 4.0 going to be released? Yes, I will tell you. Now the problem is, if I tell you the date, it will be postponed. So the question is, do you want to know the date? Yes? No? No? Yes? Yes? So the first time I announced the date, I said it was September 2012. I think it was last year. Yes, it was last year. Okay, September, yes. So the real date, our current date, is the 25th. So this week, or this next few days, we should have Rails 4.0 release, supposedly. That is our date. DHH announced the date. I want to stick to the date, so hopefully we'll have it, and we'll not be delayed. Cross our fingers. So yes, 25th. All right. Anyway, on to Active Record. Active Record. I want to talk about Active Record. I want to talk about this in 4.1 because I'm really excited about this work. I've been working with a bunch of students from different universities, and I don't really have time to go into this, but I'll tell he did all the work. So I'm going to present to you these different performance improvements and tell you what he did. And the first way to understand this is we have to talk about the architecture of active record. So it's kind of, we're just going to talk about, basically from the surface a little bit of the nuts and bolts. When you do a query, something like person.where, blah, 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 we build up this list that's basically a tree. Well, it's a linked list of different objects. And the first one is an active record base. That's the class name that you call your query on. And when you call .where, we create a new object called an active record relation object. And that active record relation object points back to the active record base class. And then when you call where again, that creates another relation object which points back, and so on and so forth. Right? So then when we haven't actually queried the database yet. We'll get to that. Then when you call to a or .first or anything like that that actually causes the records to need to be loaded, or you try and iterate over them or something, at that point, that's the point where we query the database. So I'm showing you here .2a. You may not call 2a. You might call something else, but it'll trigger 2a to be called. So we have this linked list of active record relation objects, and what happens is we instantiate an object here at the end called an arrow manager, and what it does is it actually generates a SQL AST, a tree, and it walks up each of these objects and adds to that tree. So it grabs the data off each of those objects and keeps moving up until it gets to the end, and by the time it gets to the end, then it has its entire SQL AST. Then we take the SQL AST and we actually convert that, we walk that and convert it into a string. So it actually gets converted into a string, and then we send that string off to the database, and finally get the results back from the database. So we have three transformations. Our code goes into your Ruby code turns active record relation objects. The relation objects go to SQL AST, then SQL AST to SQL statement, and then we query the database. Now in the Rails 3.2 and greater, we introduced bind parameters, and you may have run into these. They should be basically transparent to you, but you might have noticed in your logs, especially if you're dealing with SQLite, you'll see values that say like select star from people where ID equals question mark. Right? We're using bind values there. The way these bind values work is whenever you send a database, the query to the database, we say, okay, well, we're going to send this SQL statement along with these bind values, and we send those off to the database. The database makes the records, returns the records to our Rails application, and we live our happy life. Now, the first time that this happens, the database does a bunch of work. It parses that SQL, it plans the query, it executes the query, and it returns results. Now, these four particular steps may change slightly depending on the database that you're using, but that's generally the idea behind it. Now, what happens is when you're using a prepared statement, you say, okay, well, I'm going to reuse that original statement. I'm going to reuse the one that I had last time. And if you do that, then the database can say, okay, well, I'm not going to parse your SQL anymore because I know that you're reusing something, and I'm not going to plan the query anymore because I did that once already and cached it. I'm just going to execute it and send you back some results. So we save some time in the database. Query plan is cached. The parse SQL is cached. So this was in Rails 3.2 and greater, right? But we can actually do better. I think we can do better, and this is the work that my student did. So let's take a look at something. We have three queries here. We say, all right, we're going to find people where an ID is some value. All right, we have three different queries here. Now, if we go and make a table out of these SQL statements that are executed and look at the bind values, on the left there is the generated SQL, and on the right is our bind values. You'll notice that the only thing that changes in this table are the bind values on the right. The SQL statement is always the same. It's always the same. The only thing that changes is the bind parameter. If we go look at our action, we can see, well, that's really the only dynamic thing in our code. We get a parameter that comes in from the query string. That's the only thing that changes. All this other stuff stays the same. And yet, every time this action is executed, on every action, we generate that relation chain, we generate the SQL state, the SQL AST, and then we generate that SQL statement again. We go through all of these steps and then query the database. All of those steps to generate the same string every single time. All of those steps. So basically what our plan was is, we know that these things never change. So let's cache improvements that we can get on this. So here's our high-level API. We say like, well, here's our original relation object, and we're going to set the bind values on it. We just set the bind values to a random value, and then we actually perform the query on each 2A. Setting the bind values will just set the binds and not expire our SQL string or our AST cache or the relation cache. So if we run some benchmarks on this, I want to show you some benchmarks. First, we have a no cache test. So this would be our original implementation, like what you would normally use, simulating a bunch of requests with this particular query. Now we have our cached version, where our cached version, what it does is it actually caches the relation object, and you'll see right there, that's where we perform the cache. We only do that once. And then we set the bind values, and then we actually query the database. We reset the bind values, and we actually query the database. And if we run this, so we have these two queries that are exactly the same. If we run this with some names, and we just query on some names and age from the database, and we compare the two, we'll see, right here, our cached version runs at about 4,700 iterations per second, where our non-cached version runs at 2,800 iterations per second. So we can see here another very extremely scientific graph. Our cached version is actually much faster than our non-cached version. It's 1.68 times faster. And the way that we were able to accomplish this is that rather than doing these steps on every single request, we actually cached the first two steps. We're able to cache those and say, I don't want to regenerate the SQL AST again. And those of you who are astute watchers will notice that I'm not saying step 3 is cached. We can cache that. It's just that we haven't got to that. We haven't done it yet. So we're seeing these massive speed improvements only caching the first two values. We actually have more speed improvements we can get. So I want to show you how the invalidation works pretty quickly. When you say post.where name equals XXX and you call 2A on that a whole bunch of times, we actually cache that. So if you were to go do this in your Rails application today, this wouldn't query the database 3 times, it would query the database once and then cache those values. So if you go look at the branch that contains these performance improvements, you'll see this is actually the implementation of the set binds method. It's really just this long. We say, okay, we're not loaded anymore. We don't have cached records anymore, and I just want you to replace all the bind values in here. That's really the entire method. So when we do this, we say, okay, that first 2A queries the database. When we say set binds, we invalidate that cache, and then we query the database again. And as I said, we can actually go even faster if we start caching that string itself. So I think we can do even better beyond this. So the next thing I want to talk about is open source software. I'm an open source programmer. I want to talk a little bit about myself and a little bit about my job. How I got to have my job. I don't want to talk about your company. I don't want to talk about why your company should use open source software. I remember it used to be a thing, like a long time ago, companies would say like, why should we use open source? I'm not going to use this, it's not supported, it's not, I got to pay for support. I need my IBM WebSphere. Those of you other former JTE programmers here know what I'm talking about. But I don't want to talk about your company using open source. I want to talk about you using open source. I want to talk about you, all of you. I want to talk about you, and I want to talk about me. Now, why am I an open source developer? Why do I contribute to open source? How did I get started on it? The reason I started contributing to open source is because, well, I wanted to use open source to get work, right? I wanted to use this to show people what I could do and show people that I'm actually an okay programmer. I'm passable. You can hire me. I'm not going to delete all of your records, just most of them. So let's talk a little bit about the history of this. I want to talk about my open source history. Okay, my open source history and my history of getting work doing open source. Now my first open source started, I worked at a company called classmates.com. Maybe I shouldn't have told you that. But I did a long time ago. We had a thing, so we had an Oracle Oracle database, and in this Oracle database we stored, and basically what this website was a directory listing for everybody in your school. Right? It's a school directory listing website. You could go look up other people who graduated in the same class as you. And what happened was we would store everybody's names, but we would store them in uppercase. Right? And the reason we would do that is because Oracle's text search was faster if the name was all uppercase. Okay? So, and of course we didn't store the name twice because disk space, I don't know why we didn't store the name twice, but we didn't. So what we had is we had a thing, this is when I first started working in this company, it was a Perl shop. What we would do is we would take your name, take it out of the Oracle database, it would all be uppercase, and then we would do some text processing on it to correctly case it for display, right? Now, many of you may know that there are other countries in the United States besides, or in the world besides the United States. And people speak languages other than English. So very frequently this thing messed up because we were name casing for names that were like just regular American names, right? People, English-speaking United States people. But then all of a sudden we started getting a lot of Spanish-speaking people registering for our website. And while the name casing rules for English names are completely different than the name casing rules for Spanish names, so this was my very first open source contribution was to this name case library, Perl, that was like, hey, here's a flag to put you in Spanish mode. So this is my very first contribution to open source. It wasn't very much, but this was it. So after that, I got serious. My first contribution was in 2001, about or 2002. Then I got serious. And I got serious about open source in 2005. The way I got serious about open source was Lord of the Rings. It was 2005. Lord of the Rings, the third movie, was coming out, and it was coming out on there was an early screening on my birthday, and they were going to show all 3 movies on the same day, 12 hours of movies. And I was like, I gotta go to this. It's my birthday. I gotta go to this. So, all right. They announced we're gonna sell tickets online. You go to this website at 10 a.m. Of course, 10 a.m. on a work day. But I was a Java programmer. That was fine. 10 a.m. on a work day, and you buy the tickets and then go ahead. Okay. So I log into the website at 10 a.m. I'm at work, and of course the website is completely crashed. Completely doesn't work at all, and I'm like, reload, it's still not working. I'm like, okay, well, I gotta get some work done. So what we're gonna do is, we're gonna write a program that buys the movie tickets for us. So I'm like, okay, in between compiles, because compiling our application took about 10 minutes. And starting the application also took 20 minutes, or 10 minutes, so I had a nice 20-minute break there where I could write Ruby code. So that's exactly what I did. I was writing Ruby code, I was writing a web crawler and Mechanized to go crawl this website and actually buy these movie tickets for me. And yes, I put my credit card number in the Ruby file. And had it fill out this form for me. And so I'm doing it, and of course it fills out the form and everything errors, right? I know what the error page looks like. And I say, okay, just log this, log it, and then if we get a page that's not the error page, then I don't know, do something. Okay, so I got to that point, and then so it was running, and I just started working. I wasn't really paying attention to it, and I look at the terminal at the logs, and I'm like, oh no, they've changed. The text has changed. I'm like, okay, well that's fine. So I go to the website and I look, go through the process, and I'm like, oh no, this has been buying movie tickets. Over. Okay, what do I do here? I called the credit card company, and I'm like, hi! one charge to your card for $30 or something like that. I'm like, oh, great. Excellent, one charge. Okay, so I call up the theater ticketing company. I'm like, hi, yeah, I tried to buy tickets online, and I was wondering how many tickets I bought. I want to talk about getting a job, and so when I was working, this was while I was working in classmates, this previous story, and I was a Java programmer. I actually became very miserable working there because I loved Ruby so much. I used to be a Perl programmer, and then I was forced to be a Java programmer, and then I just kept thinking to myself, you know, any day now Perl 6 is going to come out. Any day now, we're going to get off this Java train and be on Perl 6. I'll have it all back. And then I found Ruby, and I was like, wow, this is what Perl 6 is supposed to be. This is what it's supposed to be like. This is amazing. It's amazing. And I was sitting there like, and this was it. So this was in Java 1.4 days. And I'm sitting there like trying to map in Java, basically. And I don't know if you remember what this was like before generics, where you had to like say, okay, as next, cast into something, like 10 lines of freaking code just to get into that collection. Anyway, it became very miserable working there because I was thinking, you know, I can just do this in 2 lines in Ruby. Literally, even 1 line. Why am I doing this? I'm spending all day, like 20 minutes compiling all this crap, only to find out that I made a mistake. I hate dealing with this. So I got a job being a Rails developer. I took a very large pay cut to become a Rails developer just because I was so miserable in my job. I became a Rails developer. This was before Rails was, you know, before people paid like regular salaries for Rails developers. So I worked at this company, and you know, I was using Rails, and actually I was pretty miserable working at that company too because it was an online advertising company. And I was using this language I loved in an industry that seemed really terrible. So in my free time to escape it, I would just play with open source stuff. We had to do a lot of XML processing, so I started doing XML writing node query and XML processing library while I was working there. And I did this to basically escape my life. So I was doing that, and you know, doing that and publishing it. People started using it, and I eventually with this job, I was like, I can't take it anymore. I need to find another job. I can't do this anymore. Like, I'm a Ruby developer, and I hate my job. What is this about? This can't be possible. So I interviewed with AT&T, and the developers there were like, well, actually, I didn't actually interview. The boss, my future boss from there, and actually my current boss now, it's a longer story. He was like, yeah, I already know who you are. Do you want to come work for us? And I was like, yes, please. So I got a job working for AT&T developing mobile applications for them, but I wasn't an open source developer yet. And the way that I became an open source developer, I'll try to tell this quickly, I know I'm going over time. The way I became an open source developer is that I was out with my wife one night, and we were out at a bar, and we were drinking, and I was like, you know, I love programming open source. She's like, I know you love it. I love programming open source. Like, I want to do this as my job. I wish I could be an open source programmer for my job. And she's like, you know what? You should do it. And I was like, okay, I will. What do I do? And then she says, you should give a presentation to your boss. And I was like, you know what? You're right. I should give a presentation to my boss. This is after a few drinks, okay? And so I get my phone out, and I text my boss, and it's like 11 p.m. on a Friday night. And I text my boss, and I'm like, we need to talk. didn't have time to work on this stuff anymore. And if I could increase the productivity of 50 Rails developers, it should easily pay for my salary, right? So I put together this presentation, showed them all the stuff that I had done in the past, and gave them a presentation over the web, and I was like, I just thought to myself, before I gave them a presentation, what's the worst thing you can do, right? You ask to be an open source developer full-time, what's the worst they're going to do? Just say no. They'll say no. You're not going to get fired. Nothing's going to happen to you. They'll say no and you go back to your normal job, right? So I gave him the presentation, and at the very end of the presentation, I'm like, so I want to be an open source developer full-time. And he was like, okay. And I was like, okay then. I actually thought you were going to quit. I'm like, no. Anyway, about a month later, he's like, all right, now a month later, I was a full-time open source developer, and I've been doing it since, so I think maybe 3 years now I've been doing it full-time. So basically the point is doing this open source development and doing open source development and doing it publicly gets you experience, right? It gets you experience through practicing programming. It also gets you feedback. You get feedback from other people in the community. They tell you, like, what are the things you do, what are you doing wrong, how can you improve yourself. You're getting mentorship from other people in the community, and then eventually you yourself become a mentor. It's also an excellent way to market yourself. So people already know you publish your open source code, people eventually start to use it. Oh, and people use the code in ways you can't imagine. Actually, I think I'm getting ahead of myself. I told you about, okay, man, so many stories. I'm going to hurry up here. All right, so you can market yourself. People use your software in ways you can't imagine. For example, like, I wrote this XML processing library, and we use it for, like, online advertising or whatever, and just stuff. And one day I get this email. I get an email from somebody, and they said to me, hi, I'm just writing you. I use Notepad. I don't have any bugs or anything, but I just wanted to tell you that I use your library to help underprivileged kids get scholarships to college. And I was like, wow, I could never have imagined that anyone would use my software for that. Like, I'm just using it for doing stupid, like, advertising processing stuff. I never would have imagined that somebody would be using my code for improving the world that way. So, I know that I'm not an exception. I'm absolutely not an exception. There's tons of people out there using open source today, like many of you here who have published some open source, even if it's just a little bit. There's somebody out there using it to improve the world, and you just don't know about it. You just haven't told you. I think it's actually a common case, and we just don't know. So I'd actually encourage you, if you're doing something good with somebody's open source project, write them and say thank you. You don't need to send them a bug or anything. Just say, like, hey, I'm using your project. I like it. I'm using it for this. Thank you. The end. It means the world to people who publish open source. So you can use this for marketing and improving your skills. I wanted to talk a little bit about my career of slacking off, but I think I'm mostly out of time here. Basically, like, I'll give you the TLDR. I was really terrible in high school. I went to college. I got a job programming to go through college. And I decided to become a computer science major while I was in college, even though I was already a programmer to pay for college. And then all of a sudden I started getting paid too much, and I was like, why should I go to college? So I dropped out, and I moved to Seattle. And then I got a little bit older, and I understood that I actually loved learning stuff. Like, I just love to learn things. So I was like, you know what? I love being a programmer. I love learning about programming. I'm going to go back to school. So I did. Went back to school. Went to college again. And I applied to the computer science department at the University of Washington. And they turned me down because my grades weren't good enough. I didn't have very good grades in college either. I mean, I had decent grades, but not good enough. They turned me down. So I'm like, all right, this sucks. So I quit, dropped out of college again. And then later on, I was like, you know what? I really, like, I love learning. I'd actually like to get my degree one of these days. It'd be nice. You know, I feel like I'm an imposter. I feel fake. Like, I say to you that I can program, but I don't actually have a degree in programming. So I feel fake. I want to be a real person. No longer a Pinocchio, right? So I go to college again, and this is my third try. I go and my grades are again too low. They decline me. Decline me to the computer science department. So I go and I talk to the head of the computer science department. I'm like, look, I know that you guys take special situations into account. Like, you say, it says in the documentation you don't base it just on grades. Like, you take people's situations into account. And I'm like, look, I'm already a programmer. I've been programming for quite a while, and I would really like to get my computer science degree. And the computer science department head said to me, well, computer science is completely different from programming. And I was like, well, F you too, and left. So that was actually the moment where I decided I don't care about college. So I'm actually a three-time college graduate. So what's really funny though is that actually I started teaching Ruby for the University of Washington. I was talking to the guy there, and I'm like, you know, I don't actually have a degree. He's like, yeah, just don't tell anybody. All right. So, anyway, yes, doing open source can improve our community. I want to talk about this. Doing open source can improve our community. In the United States, we have a program called the Open Government Initiative, so you can like get some data about the government and try to improve your community that way. I actually already talked about this, but like this is an active thing. Like, you actually have to actively improve your community with this. And when I go look at that walls of data, I'm like, I have no idea what to do with this. I really have no idea. I just like programming. But the thing is, outputting, as I said earlier, outputting any kind of open source library actually does good for the world. People use it in ways that you can't imagine, as I said already. And the last thing I want to talk about for why you should be doing open source, why you should be contributing to open source is because of the people, right? Because of doing open source, I've been able to meet amazing people. Like, I'm incredibly humbled by the people that I actually get to meet. Like, I got to meet Mats, that was awesome. I met Mats, I met, next slide, I met Chad Fowler, I met Good Cats, I met Jose Lim. I met tons of people here at RubyConf India, and it's awesome. Like, I get to go meet so many people and interact with all these people. I get to hear about amazing technology, like, holy crap, Rails. That was awesome. It was amazing. I hear about this amazing technology, and I actually want to make a point of this right now. All of you who are thinking about, well, I want to do open source, but I'm not sure what I want to do. It's standing right in front of you. This project, you've come to this conference. There's so many people around you who are actually, every one of these people is giving you an opportunity. Every one of these people is giving you an opportunity to participate in the community. Like this, I'm giving you easy, low-hanging fruit. Like, how many of you developers, before yesterday, how many of you thought about doing accessibility in web applications? I imagine it's not very many. I know I didn't. I mean, look at GitHub. Like, that example, it's not very good. We don't actually think about this. So if you want some low-hanging fruit, go find an open source project and add accessibility options to it. It's not that hard. If you can edit HTML, you can do it. So the other thing I want to bring up is Ruby Friends. Take pictures with all the people here, meet new people, post it with the hashtag Ruby Friends, and you'll see my picture on Ruby Friends millions of times because I love taking pictures of people and posting it here. So please do that. And I know I'm getting over time, I'm way over time, but I want to end with this story called Mama Died. So I am trying to lose weight. This is a graph of my weight, but it's actually really upsetting here because you'll see, like, okay, over here, this is me. I'm in the United States here. US. I think something happened there. I went overseas somewhere there. Down here, Japan, Singapore, India. And it's climbing. This isn't good. So I hate exercising. I hate exercising so much. I know I ran the 5K this morning, but I really hate it. So what I do is I do a thing called health walk. I go on health walks, right? walk by, I called them health blocks because I hate exercising, so I gave it a funny name, so I would do it. And I walked by this 7-Eleven. There's a 7-Eleven in the neighborhood. I walk by, every day I walk by, go in, I'm like, you know what, I'm working out, doing this health walk, I need a reward. So I go in. I love candy, love it. So there's these little gummy things called Mambas. And this is what they look like. I go in and I buy those, and I buy them, and I'm doing long walking because it's healthy. And then, like the next day, I'm like, yeah, you know what, I need a reward. I go in. And eventually, like the guy working at 7-Eleven, it's the same guy every single time I go there. And he says to me, I buy one day, he says to me, he says, hey, Mamba time! Go to a different store, they're not at that store, and I'm like, well, you know what, this guy can't work every day. I'll just go when he's not there. Walk by, he's there. All right, next day, he's there. Walk by, next day, he's there. He's there every freaking day, every day. I can't get out of it. So I just think to myself, well, you know what, I finally just clicked in my brain. I thought, well, you know what, like, this guy was super happy to see me come in there. Everybody that goes into 7-Eleven, they're either buying cigarettes, or booze, or dirty magazines. Like, I'm the guy that goes in there and buys candy. I am the weird one buying candy. But it actually made him happy, right? And I realized, like, he's actually getting a little, like, a good interaction out of me. He was glad to see me in his days. Like, hey, I'm happy, you know what? You're here. You're getting this candy from me. And I was like, you know what? Screw it. I'm making this guy's life happy. I'm getting some candy out of the deal. It's fine. So I went back in, bought some, and I was like, hey, Mama time. So what I want to tell all of you is I want you to find your own Mama time, and I want you to be the best Mama time that you can possibly be. And the last thing I want to leave you with for RubyConf India is I want you to write code, get work, and make friends. Thank you very much. All right, questions? Yes? They don't have to be technical, you can ask, but they could be technical too.
Okay, hey Aaron, great talk.
Thank you.
I just wanted to know, can you do a seg fault with Fiddler?
Can I do a seg fault with Fiddle?
Yes.
Yeah, absolutely, yes.
Okay.
Definitely. So, you can access memory anywhere you want to and do anything you want to with it, so you can absolutely seg fault, for sure. and it's not a bug.
Yeah, great talk. Just a performance question about MRI and JRuby and stuff like that.
Sure.
Where do things stand right now with Ruby 2.0? I hear that there's a global lock still in Ruby 2.0, so JRuby makes a better choice. Where is the adoption curve right now? And it's been like more than 2 to 3 years. Can you just give us some idea where things are there?
Let me repeat the question.
I mean, you're a JDE guy, former JDE guy like me, so I can ask you, maybe DHH would not like this question, they just use MRI.
So let me see if I get the question right. What is the deal with the GDL? Is JRuby still a better choice for performance? Is JRuby still a better choice for performance? That is a loaded question. You can't ask it that way. So it depends on what you're doing. It always depends on what you're doing. If you're looking for startup time, obviously JRuby is not the choice for performance. it's definitely faster still, for sure. Yep. And if you want to do like multi-proc stuff or multi-process stuff, JVM is definitely the one to go with. Though I still prefer MRI. I want the Ruby core team to have to. Yes, you're welcome.
Hey Aaron, thanks for the amazing talk. So about Fiddle, yesterday Osmarin took a talk about security and how you can exploit a system, and he got into a Rails application system because of the JSON vulnerability that we had some time back. So Fiddle is gonna make it worse, I think. So have you got a chance to put some locking around, or thought of how you could not allow any hackers to use Fiddle in a bad way, right? I mean.
So the question is there any way for hackers to protect against people using Fiddle in a bad way? And the answer is no, there's no way. Like, basically that thing, if you use Fiddle, you can do extremely dangerous things with it. It is not, like, you don't use it. I mean, use it for having fun, but I would definitely not expose it to people, especially because of the crazy stuff I showed you in these slides, right? But the thing is, the thing you have to remember is that you can't get, it's very difficult to get people to load arbitrary code. And even if you got them to load arbitrary code, you'd have to inject something in there that said, okay, I need you to execute some Fiddle commands too. So it's extremely low risk, and if it was possible, this would be like a major, huge security issue. Like, I wouldn't worry about it. Just don't use Fiddle in your applications, probably.
Yeah, because the reason I ask is I tried thinking of, I had searched for allowing a gem lock, not allowing any user to not be able to install gems or require gems in a console or something, and I didn't find something useful. So if you have, I'll maybe talk to you later. But if there's something like that, then yeah.
So you're looking for ways to prevent people from requiring files.
Requiring gems, basically.
Sure, or requiring gems specifically. Yeah, there's various ways you can do that. Let's talk about it after.
Yeah. Thank you so much.
Yeah, you're welcome.
We have one last question, please.
Yeah. Hello. Here.
Sorry.
Do you see active support using refinements anymore soon here?
Where are you? Okay.
Yeah.
Okay.
Do you see active support using refinements anytime soon, or is this that it's just impractical Ruby?
The question is, do I see active support using refinements anytime soon? Not soon, no. So I started a branch. I have a branch on my machine here that uses refinements in active support. What were the problems I ran into? I ran into problems, I can't remember specifically what they were. Basically it was backwards compatibility stuff. If we isolate active support using refinements, then we need to get other people to use basically the refined version of that. So it's difficult to supply people with backwards compatible gems. We could probably do it in the future, but I doubt it'll be anytime soon. And actually, one note I wanted to say about using refinements is I think refinements are actually pretty cool from the perspective of, okay, let's say you have a class. Okay, I'll say this really quickly. Say you have a class, and one of the methods uses something from active support, like downcase, or not downcase, I don't know, camel case, something like that. And you didn't require the file at the top. You didn't require active support at the top. Your class has a runtime dependency on active support, but it doesn't have a compile time dependency. So you can load that class in, and as long as you don't call that method, then everything's okay. You don't get an exception. But what's cool about refinements is it actually makes you bring that class in at compile time. So when you load the file, you actually have to reference that class, and if that class isn't there, like the active support refinement class, if it's not there, then you get an exception. So you can actually see what your classes depend on. Okay, anyway, yes, sorry, next question.
So this will be the last question, and I promise it will be a very, very short answer. But it will be a long question though.
All right. The answer is yes.
Okay, so Aaron, loved your talk. My name is Aman King. I had this very relevant, very important question about the caching stuff that you and your student are doing.
Yeah.
By the end of your talk, I thought, screw it, forget it, that's not relevant. I think you're far more interesting as a person than as a programmer. So my question to you is, and I love cats, how old are your cats?
How old are my cats?
And I want that sticker.
Yes, okay, so the two questions. How old are my cats and can I have a sticker? Yes, you can have a sticker, absolutely, come find me. The Gorbachev is about 3 years old and CPAC Airport YouTube is, she is about a year and a half old. I got Gorbachev with a stud cat. Let me explain what stud cat is.
Did you see me fall on stage?
He was the male cat for a breeder, right? And the breeder did not want him anymore. He was done. And he said, what's crazy is he was done being a breeder cat at 3. So the breeder was done with him, and we were like, yeah, well, we love him, so we'll take him. So that's how we got him. We did not have him since he was a kid. He's had full life.
All right, guys. If you have any more questions and you don't recognize Aaron, search for the man in the suit. All right. Thanks a lot, Aaron. Thank you.